In this video lecture, I'm going to discuss how to name coordination compounds. We will use an example for this slide of FeCl2 H2O4Cl. So we need to remember these rules that we're required to follow. Number one, determine the name of the non-complex ion. So the non-complex ion is what we're looking at outside of the coordination sphere. And in this case, that would be Cl, which we know is minus, Cl minus, and that we know is called chloride. Number two, determine the ligand names and list them in alphabetical order. Looking at our ligand names, so remember the ligands are the things that are attached to the metal center within the coordination sphere. So our ligands, we have Cl, which as a ligand is called chloro. We have to memorize that. H2O as a ligand is called aqua. So our ligands are aqua and chloro. Step three, determine the name of the metal cation. Our metal cation, that is our metal center. So the metal cation here is Fe, which we know is called iron. We also need to determine the charge or the oxidation state. To do that, remember the entire complex adds to a charge of 0. The counter ion has a charge of -1. Aqua is neutral. Each chloro is -1, so two of them are -2. So we have an overall -3 charge, which means we must have an iron with an oxidation state of +3. So iron 3 plus is named iron 3. And now rule 4, we're going to name the complex ion. Name each ligand alphabetically, adding a prefix in front of each ligand to indicate the number found in the complex ion. So for part A, that would be, we have aqua and chloro. Aqua, we have 4. The prefix for 4 is tetra. The prefixes are listed in your study guide and on a slide we're going to look at in a moment. So we have tetra, aqua, and now we have chloro. There's 2 of them, so that would be dichloro. And now we're on step B, followed by the name of the metal cation, iron 3. And then that is how we name our complex ion. So tetra, aqua, dichloro, iron 3. The complex ion. And then step 4, write the name of the cation followed by the name of the anion. So just like our standard ionic compounds, for example, sodium chloride, we say sodium first because sodium is the cation, Na+, chloride is the anion, Cl-. So in this case, our cation is the complex ion, so that is listed first. The anion is an anion, or the counter ion is an anion, and that is listed second. So the name of this coordination compound would be tetra aqua dichloro iron 3 chloride. The only space is between the 3 and the chloride. You can also have a counter cation that would go first, followed by a complex anion. We will continue on and look at more examples over the next few slides. This is a reminder of what's in our study guide for chapter 25. This page number is not correct. And a list of the ligands we've been discussing. One important note here, we use bis and tris as prefixes because the name contains a prefix for ethylene diamine or EDTA. So our prefixes are listed right here, and I can see that di is the prefix for 2. Di is also in the ligand ethylene diamine. So if you happen to have 2 ethylene diamines, you would write down bis, parentheses, ethylene diamine. If you had 3 ethylene diamines, you would write down tris, parentheses, ethylene diamine. Now we're looking at names of common metals when found in anionic complexes. So our previous example, we had a cation that was our complex ion, and so we used just the name of iron. If we happen to have a complex anion, so for example, FeCl4 2 minus, I know each chloride is -1, so that's overall -4. This is +2. But what's important here, it's an overall 2 minus charge. So we would name the metal center not iron 2. We would name it ferrate. So this would be called tetrachloro ferrate 2. And the reason we write ferrate ending in ate is because the complex has a 2 minus charge. Remember, your metal center always has a plus charge. So we'll go over these examples. So these names, again, you do need to memorize them if you don't have them already in your vocabulary. Let's look at another practice here. So in this case, again, I can see that outside of the coordination sphere, I have my Cl minus ligand or counter ions. So I have 2 chloride counter ions, which means my coordination complex has a 2+ charge. So that's something to remember. So I know my counter ion is called chloride. Again, I know my ligand, I have chloro and I have amine. In alphabetical order, we list amine first. And spelling is important, especially with Alex. We spell amine, A-M-M-I-N-E with 2 M's. That we list first. And then we have chloro. I have 5 amines, so that's penta. Amine. I have 1 chloro, so we leave it just as 1. Now I need the oxidation state of my cobalt. Well, I know that each of my chloride counter ions is -1, so that's -2, and -1 chloro ligand, which means cobalt is +3 for the oxidation state. So the name of the metal is cobalt 3. We name the cation before the anion. We have a complex cation. So I list my ligands in alphabetical order and then add the prefixes. That would be penta, amine, chloro, cobalt, 3, second word, chloride. So again, it's chloride because that's our counter ion. We have chloro as a ligand. We alphabetize the amine before the chloro and then add the prefixes. The only space that we have in this name is again between this parentheses and the C of the counter ion. So just a couple notes that will help you memorize the names of the ligands. We'll go over these together. The names of anionic ligands end with O. The endings of the neutral ligands are not changed. For example, chloride is an anionic ligand. We name it chloro. Bromide, bromo. Nitrate, nitro, etc. Prefixes tell the number of a type of ligand in the complex. If the name of the ligand itself has such a prefix, alternatives are used. And this is our example. So tris ethylene diamine means we've got 3 ethylene diamine ligands. If the complex is an anion, its ending is changed to ate, right? So ferrate, cuprate, etc. The oxidation number of the metal is listed as a Roman numeral in parentheses immediately after the name of the metal. So these are notes that we discussed in the previous slide, just stating them again for clarity. Here's a couple practice problems. I encourage you to pause the video, go ahead and work on answering these, and then we will come back and go over them together. Let's go over these together. So number 1, I see my counter ion is nitrate. I see the ligands that I have, amine and bromo. And I see the metal center that I have, MO, is molybdenum. And we need to figure out the charge. So for the charge, I know I've got 1 counter ion nitrate minus 1. I have 3 bromos for a total of minus 3. Amine is neutral, so molybdenum must be plus 4, which is IV in Roman numerals. So to name this, we name the ligands first in alphabetical order, and we add the prefixes. We have 3 amines, so triamine. 3 bromos, so tribromo. Molybdenum 4. And then the second word is our anion, which is nitrate. The reason we put the counter ion last is because we always list cations before anions, and our cation is our complex cation, and the anion is just the simple counter ion. The reason that molybdenum does not end in ate is because we have a complex cation. I know this is a complex cation with an overall plus 1 charge because I have only 1 counter ion with a minus 1 charge. Looking at the second example here, I see that my counter ion is ammonium, NH4+. And I have 2 of them. I have 2 counter cations, which means this complex is a complex anion. The name of the ligand is bromo, and I have 4 of them, so that will be tetrabromo. And Cu, it's a complex anion, so this becomes cuprate. Again, we're ending in ATE because this is an anionic complex. The name of cuprate needs Roman numerals. To do that, we have to figure out the charge of our copper ion. I know that each ammonium is plus 1, so we have plus 2 for the ammonium, minus 4 for the bromo, so copper must be plus 2. I can also think about that if I'm looking at just the complex anion, CuBr4. I know that each bromo is minus 1, total minus 4. In this case, if I'm looking at just the complex, plus 2 and negative 4 give us that negative 2 charge. So this becomes cuprate 2. To name this, we always name the cation first. So our cation is our simple counter ion ammonium. Notice it doesn't matter how many ammoniums we have. The number of counter ions doesn't matter. You just need the name. Just like if we have MgCl2, it's magnesium chloride, not magnesium dichloride. You do not use prefixes for the numbers of ions that you have. So we have ammonium, and now we're going to add our tetrabromo, cuprate, 2. And this is the answer for the second one. The last part, we're given a name, we want to write a formula. Sodium, I know that means I've got a simple counter cation. Diaqua, that means I have 2 aqua ligands. Dioxalato. So our oxalato ligand, C2O4, 2 minus, I have 2 of them. Ruthenate, well, ruthenium is Ru, and we're told it's 3 plus. The reason we're ending in 8 is because we have a complex anion followed by a counter cation. So I'm going to start by writing the chemical formula for the complex anion. I know the metal is listed first. I then list the anion ligands. So oxalato, C2O4, I've got 2 of them. And then I have water. Aqua, also 2. So looking at the charges, each oxalate is -2, so that's an overall -4. I know that aqua is neutral. We're told that ruthenium is +3. So that gives the overall coordination complex has a -1 charge. So in the chemical formula, that means I need only 1 sodium to neutralize that out. So the formal answer, we would want to make sure to not include the charges above. So just to rewrite this, our final answer, NaRu C2O4 2 H2O2. So hopefully this provided a few good practice problems. You will have additional practice in your homework.